Hi, welcome to this video. We're going to develop the problems in application 1-4 of the chapter 27, the basic tools of finance. Remember, this is a book of Gregory Mankiw, Principles of Economics. So the first question says, according to an old myth, Native Americans sold the island of Manhattan about 400 years ago for $24. Then we already have here the period, so we have 400 years, and then the present value should be 24. If they had invested this amount at an interest rate of 7% per year, how much approximately would they have today? So then the interest rate should be 7%, and remember the formula that we have seen during this chapter, that the final value is exactly equal to the present value times 1 plus the interest rate elevated to the period. In this case, we need to find out the value of the final value. So then we just replace present value should be 24 times 1 plus 7%, which is exactly equal to 0.07 elevated to 400. This one is an extremely huge number. How come? Since we are talking about 400 years and we are talking about 7%, naturally the factor that you are going to multiply this present value is going to be huge. Then, making this multiplication, we have this one. Remember that when we have 9 zeros, should be a billion. Then here we're talking about 12. So we are talking about approximately 14 trillions of dollars. Second, a company has an investment project that would cost 10 million today and yield a payoff of 15 million in 4 years. A. Should the firm undertake the project if the interest rate is 11%, 10, 9, 8%? So first of all, we need to find the interest rate of this specific project. We already know that the final value is exactly equal to this. We already saw that. But in this case, I'm going to collect, or I'm going to isolate the I term in order to find out the value of the interest rate. So then, when you have this one elevated, you need to make like the square root of this in order to isolate and collect for I, for the interest rate. So I just elevate to 1 over n in order to cancel this one, and all this I elevated in 1 over n. Then here I have exactly the same by the properties or the law of the exponentials. When you have something that you are multiplying and these two, they are elevated, this is split in the two terms. So then you have the present value elevated to 1 over n times 1 plus interest rate elevated to n over n. This is another law of the elevation property, because you have n, it multiplies. So then you should finish n over n, so you can cancel it out. Then this is multiplying, so I can put this to the left part. You can put that dividing, and then you have 1 plus e. You can collect a little bit better, or just to order, because these two, they are elevated to the same, which is 1 over n, so you can take both final value over present value elevated to 1 over n minus 1, and this should be exactly equal to the interest rate. Just for order, it should be better to have our variable in the left part, but it's exactly the same. I just replace the values, should be 15 and 10. There are millions, so it doesn't matter, I can put in that way. And then I have 1.5 elevated to 1 over 4, because 4 is the number of the years. And then this is the value of these expressions, and then you compute, and then at the end you get this value. If you multiply by 100, you automatically you will have the percentage. As you know, this is approximately like 11%. So this is like the interest rate of this project. So if it's higher than this, should be okay. Otherwise, this project should be the best solution. And actually, with this answer, with this number, we can actually answer the second part. Can you figure out the exact cutoff for the interest rate between profitability and non-profitability? They should be exactly equal to this one. If it's higher to this one, we're saying that it's like this one will be more profitable. Otherwise, under this one, this is not profitable. Third, bond A pays 8,000 in 20 years. So here we have the final value, 8,000, and the number of periods, 20. And bond B pays 8,000, exactly the same. However, it takes 40 years. It says like to keep things simple, assume these are zero coupon bonds. Remember, coupon is something that is paid by the bonds in certain periods of time. But in order to keep these things easy, we are saying that is zero coupon. So which means that 8,000 is the only payment the bondholder receives. A. If the interest rate is 3.5%, what is the value of each bond today? Then here we have the interest rate for this bond. Here they provide a hint. We can use calculator, but the rule of 70 should make the calculation easy. Actually, I use the formula because for me it's like kind of easier. But if you can use the rule of 70, it's an option. So here we have the interest rate. So here we have the formula. I just replace by I collect by the present value. So the present value is exactly equal to final value over this. So then you just replace 8,000 over this. This is the interest rate, 3.5% over 100. It makes 0.035 elevated to 20. Then you have this factor of discount, and then the present value of the bond A should be exactly this one. What about the other case? The other case already you have this formula. You just replace, instead of computing by 20, you compute by 40, and this the factor is naturally higher. So for this reason, the present value should be lower. Actually, this was the question, right? So what is the value of each bond today? B. If the interest rate increases to 7%, what is the value of each bond? Which bond has a larger percentage change in value? So here we have the bond A and here the bond B. Now we have different interest rate, which is 7%. You have exactly the same formula. You just replace, instead of computing by 3.5%, you compute by 7%. And then you have this factor of discount, which is naturally higher because of the increase of the interest rate. So then the present value of bond 1 should be this one. What about the second one? The second one you make exactly the same, should be 1.07 over 40. The factor of discount is huge, and then you have this one, the present value. Again, the present value of the bond B is lower than the present value of bond A. What about the percentage change? So here is the situation. You have the first, with the interest rate of 3.5%, we have this value. With the interest rate of 7%, you have this value. You make just this simple percentage change, which is the final value minus initial value over initial value. You just replace the numbers, and then you have here minus 48.58%. Why is negative? Because it was a decrease. What about for the bond B? Present value and present value 2. Then you just compute, and then you get this one. Naturally, this huge, or is higher, the percentage change for the bond B. Then, based on the example above, complete the two blanks in this sentence. the value of a bond when the interest rate increases. You already saw that when we increase from 3.5% to 7%, automatically the price of the bond decrease, rise, so falls. And then when the interest rate increases, and bonds with a longer time to maturity, which is the bond B, which it was 40 years, are more sensitive to changes in the interest rate. 4. Your bank account pays an interest rate of 8%. You're considering buying a share of stock in XYZ Corporation for 110. After 1, 2, 3 years, it will pay a dividend of $5. You expect to sell this stock after 3 years for 120. Is XYZ a good investment? Support your answer with calculation. So we have like two projects we need to evaluate, which is the higher final value, and the one that provides a higher final value is the one that you need to choose. Then, if you imagine that you put the money in the bank, so you, and the other situation you have like initial value, which is 110. Definitely this should be the present value. This situation of 1, 2, 3, dividend of 5, and the price that you will sell, this one should be 120. If you do not invest in your bank, sorry, this one, if you invest, okay, let me just correct this one. Okay, if you invest in your bank, what's going on? So if you invest in your bank, you have final value 110 times 1 plus the interest rate that it provides by the bank. And then 3 should be the years that you are able to leave this money in your bank. So then you have this one should be, this is the factor of multiplication of 110, and then you have the final value 138, around 39. What about if you invest in stocks? You have the final value should be the final value 120 plus 3 times the interest, the dividend, which should be 5. And then you have 120 plus 15, then you have 135. In this case, naturally, it's better to keep the money in the bank. Okay, I hope it has helped. If you have any comment, any suggestion, or maybe you see something that could be even wrong or something like that, I'm more than open to receive that comments. Thank you so much, and see you next video. Bye bye.